Hello, hello, hello. Is this working? Hello, 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 hello. Yes, it is. Okay, cool. Right, back to where we were. Um, I'm back with a coffee. A really nice coffee, actually. Okay, let me just enjoy this. Yeah, pretty nice. Um, okay. So I wanted to just check what was actually coming back in this. So I'm going to set a debug point and I'm going to take a look. I am intrigued. For X in Y in test data loader, spot the spot the mathematician kind of variable naming there. But yeah, I can see, I think there is a debug window here somewhere. Here it is. So I just had to remind myself for X. So Y is the new variable, but what the hell is X? I've never seen this syntax before. Let's see. Python for loop. Python for loop with comma. The function population generator is returning a list of tuples which are unpacked automatically into variable names using this syntax. So basically you're getting something like the following as return value from the function. Given this example, in the for loop's first iteration, the variable position and target will have the values pos and target 1. Oh, that's so gross. That's so interesting. What? Why would it do that? Oh, that's so interesting. So if I go test data loader here, and it's giving me shape and D type. So if I can find it, shape and D type. Ooh, I don't know how these work, you know. Um, Data loader is a data loader object. Go here. um, Get iterator. Single process data load iterator returns that. And this has dataset. So this is what I'm looking at here. Dataset, yep. That's a load of dataset, and that will have, whoops, that one there. Nope, I've lost track now. But I can see that it's that. Oh, here we go, dataset. Get item returns a TCO. Covariant. This is so interesting. There's the data. Oh, here we go. Okay. We got it. We got it. So in this case, the dataset's data would be um, shape is, so this is Y, that makes sense. But what the hell is X? What? I'm such an idiot. Like, how do I understand this? Let me just see what a tensor is, because I think I know what a tensor is, but I'm just gonna algebraic object that describes a multilinear relationship between sets of algebraic objects related to a vector space. Objects that tensors may map between include vectors and scalars, and even other tensors. Tensor object shape. Whoops. Schema. Let's have a look at that. It's a JavaScript TensorFlow. We'll feel a bit sick. We have utility functions for common scalars, cases like scalar 1D, 2D, 3D, and 4D tensors, as well as a number of values D-type. The values of the tensor can be nested array of numbers or a flat array or a typed array. If the values are strings, they will be encoded. I see, so pass a nested array of values to make a matrix or a higher dimensional tensor. The reason I can't understand it, because like I understand what it's doing now. If I did like Python online runner thing, sure. And if I did something like I don't know, hello, and that was an array, and I think what it's saying is that say A is 1, A is 2, and if I do a for A, B in in hello, then print string A dot A, and then print B dot A, and that will return name A is not defined for A, B in hello. So what the hell is... Okay, now I'm confused. Name A is not defined. Now I'm really confused. So let me go back to that description. For loop in Python with comma. Underscore is an argument that has no name, a placeholder of sorts, so it's declaring two arguments, underscore and p. Yep. And what goes to these arguments? Underscore and p are given data dot iterable rows, probably a tuple with the variables representing the return data respectively. I don't think that's very helpful. So look at this. Come on, give me an example. Ah, the function population gen is returning a list of tuples, which are unpacked automatically into variable names using this syntax. So basically you're getting something like the following as return value from the function. Given this example, in the for loop's first iteration, the variable's position and target will have the values. Does it also work with tuple unpacking? Print A, print B, print next. So am I to think then that I cannot do this, but it just works in arrays? I wonder. Let us see. Because then you would imagine that, like, it makes no sense. Array of... This makes no sense to me. What is this? What are the brackets? I don't know Python. Python square. I mean, let's just do it. Let's just run it. What does this actually represent in Python? Like so. Okay. And what is that? So let me put this into here because I'm very interested now at how this actually bloody works. Because I have not got a clue at the moment. Run. Cool. Okay. So hello has become. Oh, so a tuple is an actual object definition in Python. So Python tuple store multiple items in a single variable. It's an object, isn't it? What's the difference between an object and tuple? Interesting. Tuple items are ordered, unchangeable, and allow duplicate values. Tuple items are indexed. The first item. Difference between tuple and object. List of multiple objects which can tuples on the other hand. Okay, perfect. Yeah. Anyone wondering how they differ? This is a surprising common question. They both behave in a very similar way. Both lists and tuples are sequence data types that can store a collection of items. Each item stored in a list or a tuple can be of any data type, and you could also access any item by its index. So the question is, are there differences? And if not, why blah, blah, blah. The main difference between lists and tuples is the fact that lists are mutable, where tuples are immutable. So it means immutable data type. I mean, what about a constant? Let's create a list and assign it to a variable. Yeah. We can get an error saying that a tuple object doesn't support item assignment. But you might be thinking, Karen, my man, I know you can't do assignments. Let's see, the answer is no, absolutely not. Variable and object. You're probably confusing variables with objects. It's very a common misconception among beginners. Oh god. I'm not a beginner, but sorry. Remember that a variable is nothing but a reference to the actual Python object in memory. The variable itself is not an object. For example, let's try. Um, great, great. Oh god, it's just going off on one. Don't want a list and a tuple. Yeah, it's so strange. Because I would make this a variable with properties. I guess in data science it's not required. Let's see, tuple in C#. Yeah, never used them before. Interesting. I have never ever used one before. So if I did this, what happens now? I feel like I'd be missing out on some fun here. Yeah, okay, it's interesting. Right, okay, well that helps. So that really does help to understand what that mechanism works like. Close multiple tabs, close tabs to the right. So in this case, we see there's something interesting about the capitalization of X and a lowercase y as well. What are they trying to say to us? Not sure what they're trying to say. Um, I suppose x is of some kind of significance. Let me try this one. It's like a noun versus a class versus a variable. But x has become the first part of the tensor and y the second. And let's look at this batch sizing. So this was test data loader, and the batching side is 64. So let's see what 64 actually means. I'm guessing there's 64 sets of 64. Okay, cool. Yeah, that makes sense. And that's interesting too, because it seems to be a very nested rather than an array of. Huh. That is a very deep object. No, it's not. These are all the same values. Okay, fine. Fine. And then what we got here? So, and why is that capitalized? 921. Let's see, this one x is different because. Can I see this view? Here we go. Oh yeah, this is better. Okay, fine. And then y is. So where's the view like this? Show value expression, copy value, compare value with clipboard, jump to source, jump to type source. Value expression. Um, Data. I should be able to view that. Can I double click on it? Okay, well, it is. What does the value actually look like? You see, Notepad, Visual Code. Oh wow, nice. Oh, that is it. Okay. So it's like the other one's like some kind of structure. This is a list of 64 numbers, isn't it? Can I count commas in here? Get count. Oh, I really want Notepad++. Let me just go and download that. Or count search visual code. Let me see if there's a plugin for it. Once you've the search bar, Control F, click the triangle on the right hand side, on the left hand side of the search. Oh, 63063. Okay, cool. So it is, okay. That's interesting. That is interesting. Right, we are learning, that's great. So it's the batch size. So that's all it is. There is a bunch of numbers, and I think they're weightings, and I guess it's going to tell me that, but automatic batching, sampling, shuffling, and multiprocess data. Here we define a batch size of 64, i.e. each element in the data loader iterable will return a batch of 64 features and labels. Features and labels. So where's the labels on these? Interesting. Dataset fashion mthis, number of data points, test data, classes, data, view. So they don't seem specifically labeled, but I'm guessing because these represent, these are we'll have to find out, I think. So out, shape of x, let me actually just run this again. This is fascinating nonetheless. Um, Python console clear event log. Not sure what that is. Not sure what that is. Stop and then run again. Console. That's what I wanted. So if I continue this, so the shape of X is 64N, 1C, 28H, and W. Read more about loading data in PyTorch. Okay. To define a neural network in PyTorch, we create a class that inherits from nn.module. We define the layers of the network in the initialize function and specify how data will pass through the network in the forward function. So there's two virtual methods that I can override. To accelerate operations in the neural network, we move it to the GPU if available. Okay, that makes sense. So here's our class. Inherits from the nn.module, and here's the initialization that it spoke about, where we define the layers in the network, and this is initializing the base class. Then it does some flatten, whatever that means. Stack linear ReLU stack, regular linear something. I wonder what ReLU stands for. Rectified linear unit. Okay. Okay, cool. Fine. And then this forward march that's happening here as part of the nn.module. Looks like I've maybe overridden maybe it's an interface or something. Model equals neural network to device. Okay, well, fine. Let's just grab this. Let me think about this somehow. So I'm gonna have to zoom out a bit because it's a bit difficult to see what I'm doing. Maybe I can just collapse this. Yeah, cool. So I've got a machine learning class. I'm going to run stuff, but actually I need more in the setup. So maybe this was a little bit silly. Let's try this. Device equals CUDA if torch.available is available. Okay, device is CUDA if else CPU. So the setup does actually work there. Cool. So let's do that. So device is a string and equals CUDA, and I don't think I can set things. Yes, I can. Great, that's cool. Else CPU. So let's do that, and then if that, then if if is CUDA available, then that will device will for goodness sake, device equal CUDA. Else device will equal CPU. Okay. Check if CUDA is available. Setup check. Yeah, let's move this into its own thing. Define is CUDA available. That's all good. And this will run this. Okay. Self dot. So I want to do set device. Okay. Set device. Right. And then what we got here. So this is our separate class. So let's try that. Oh, and you know what? Let me just start to fatten out this a bit. So let's do a directory, and we'll call this models. I'm going to call one neural network. I don't know how do Python people do this. We'll just go for that, doesn't really matter. The file neural network is not associated with any file type. Please define the association. It's a folder. We just created a folder. Did I not just do that? Oh, no, I didn't actually. Okay, delete. Okay, new file. It's a Python file. Neural network. Okay, add. And that's going to be this. And it requires what? I want to move this to my machine learning. Like that. Machine learning. Add that file too. And what we've got in here. This requires this stuff. And this should be that. Like so. And then I want to import from machine models dots machine learning. I can't actually remember how to do this. That maybe import. How does this look? What did it just change? As machine learning? Okay. Interesting. That was a good guess. And then this is not going to go here. This is going to go in some neural network class. Neural network to device machine learning. It's going to go here. And let's do run one or run train data download download data set up loader it's not a string. It's not a string at all. It's an any because I have no idea what this returns because when I go through to it, it doesn't tell me. Fashion mnist dataset. Doesn't tell me. Because why not, eh? Whatever. So this needs to be self dot. Whoops. Self dot. And then this will be the data loader. Well, actually, no, I don't need this yet. So set up loader. Yeah, I do. Self dot train data loader. That one. This will be none. None. That's correct. None. And then test data loader. Training data. No, data. Loaders. Okay, and then this will be using the train data. Although, what would be better is if this gets past it. Right. So now I go and download the data. This could actually return the data as an object. So let me put this into its own class called training. So data. It's called data. Yeah. Yes. Then datasets was declared where? Datasets is found in here. And then we'll do class data. And it's going to be literally like this, I guess. Maybe an init. Yeah, something like that. Oh, how do you do that? Initialize. Oh, that. Maybe a define. Yeah. And then we're going to do like so. No, this is fine. That's fine. That's fine like that. That's fine like this. Equals none. Equals none. This will be public. Okay. And I'm going to import that data. Models.data as data. And then this is going to be returning data. And this will be data equals data. And then it's going to be data that, return data. Then it's going to set up check, run. Where's my run? This is machine learning. That's neural networks. Where's my run function gone? I collapsed, didn't I? I know I collapsed you somewhere. Oi, oi, oi. Where did I put it? Alright, well, whatever. Whatever. This could be part of the setup. So set device self dot download data. This gets returned a data downloaded data equals data. Okay, and then downloaded data is passed through into my setup loader self dot self.load. Yeah. How are we doing over here? Yeah, I think you can roughly see. Cool. That doesn't need to be that, sorry. That needs to be that, yeah. Now the data gets passed into there, so that makes sense. And then setup loader should return the data loader. So let me go and make another one called a data loader. Data loader. Whew. Data loader, and that's going to that's fine. This is just, yeah, it's just because I want to get most of this scrap out of the way, and then I can go to individual files and know what they do, and I can document them. So I think this is a good idea. Interestingly though, data loader has already taken things, so I'm going to call this data loader example data loader, something like that. That's fine. And then this will do that. Those two. Yeah. So it's going to be terrain and test, and data loader comes from this one. Perfect. And this needs training data. So so I'm going to do a define init, and I'll do that, I guess. Self dot. You know what? That's not a good idea. Let's do this. Setup. That's fine. This will have training data and test data. Although I would just assign it anyway. So I just want two, yeah, I just want two things. That's fine. Yeah, that is totally fine. Let's just do that. Equals none. Equals none. And then I want to do data loaders. Whoops. Example data loader. This will help me. Yeah, that's so cool. Will it help me here? Okay, data might be taken. That's interesting. Models.data. Does this say no module name data? Why is that? That's interesting. Probably because of the. Is this even a thing? The sole value of the type none is frequently used to represent the absence of value. Yeah. So why is it squiggly? No new line at end of file. All right. And what are these squigglies for? Typo in word data loader. No, you're fine, you're fine. And that one needs an extra, yeah. I need to get this done because I'm gonna lose my brain in a second. What is this complaining about? No module name data. Example data. I wonder if data is maybe a taken word or something. Excuse me. Models. That should work. I mean, it's done this. Example data loader. Oh, okay. You have to do from. Aha, okay. Whoops. Fine. From models. Import. Oh, and it's not actually that, is it? It's that. Of course. Okay, understood. Right. So what I was doing there was I was referring to the class inside, but obviously this is Python, so it's working with these folder structures for the namespacing. So it has to be what I've called it, and then I can go and get the class from that file, which makes sense. Cool. I think should I change that back to? I think I'll keep it as example data because this really is just to help me, and there's nothing particularly special about this, so I don't have to do it properly. Data loader, example data loader equals that, and then you've got this and that. Beautiful. Yeah. Okay, and then it's going to be in that. Whew. Setup loader, and then this is going to run it. So that doesn't happen, that returns the data loader, and that means that's going to return. Is it like that? Or is it like that? Example data loader, like that, and this one returns example data, yeah, and then so this will be data loader. Here's a example data loader, and then I've got my run function again. Awesome. Define run. Shit. Okay. And I want to run against my data loader, which I'll pass into the function again. So the data loader returns that, and then there's going to be a data loader. Shame I went with the one word instead of the two now. That is example data loader, and then this will be self.run data loader. Right, I can scroll those away now, and then I've got my run function, which is awesome. So setup check is not what I want. I want this to be set up. And so in my main, there's going to be machine loading setup, and then I'm going to run it. So setup should have an access to this. So this should be data loader, and it's going to be a example data loader type. I don't think I need these now. Yeah, so that self.data loader is just going to equal that. And then the run method will probably be on the neural network class instead. But we will keep it here for now. I don't want to pass this in, I don't think. I want to just run it from itself, because we set up the data. Yeah, okay, we'll do this for now. Yeah, okay. And then that means run doesn't need anything from there because it's all self-contained. Machine learning is there. Machine learning is here. Uh, example. Setup's gone. Setup device gone. Clean this up. What is this saying? Typo in. Okay, yeah. So I mean, can I correct that everywhere? Rename to. It's probably not worth it. Yeah. Okay, cool. Let's just run that. I think I'm gonna have some errors. Yeah, machine learning example. Module object is not callable. Module object is not callable. From that, import that. Machine learning.setup. Setup loader, missing one argument test data. Setup loader missing one argument test data. Right, that's correct. This takes, instead of that, it will take this. Data that, and then this will go data dot. Cool. What we got now? Oh yeah, okay, cool. Right, let me just say all that. Get status, that looks about right. Models, PyCache. Yep, data. What's in my data folder? Fashion MNIST. Ooh, do I want that? Yeah, I guess not. So let me add that to my git ignore. Data. That's gone. Okay. And then the rest looks about right. Yeah. So git add. Whoa, what was that? Git commit. Just reorganized project a bit to make easier to read. Git push. Okay. Nice. So now I've got all of that set up. I'm going to go back to this example. It's got all this stuff, and it's going to print out that. Right, and that means I need to close this, close that, get my neural network up. nn.module. Now, where's the nn stuff? This one. That's sorted that. Logits. Okay, logits equals. Okay. So it initializes some stuff. The forward method is something that you have to override. That makes sense. And then we can see the output, and that's going to go into here. So my run will no longer be like that. It'll actually do this. So import that, please. Oops. Import, and device will be from here. So it's interesting how those are those yeah, because I've just only got a print here, and so really it requires that device thing to be. Oh no, I see. No, it doesn't. Okay, fine. Let's put that in. Oh, that's nicer. Okay. Now if I run that, we should get output. Awesome. Okay. So, and what was this about? So, to define a neural network in PyTorch, we create a class that inherits from a module, define the layers of the network in the init function, and specify how data will pass through the network in the forward function. To start operations in the neural network, we move it to the GPU if available. So, just rerunning around this, if I go to my neural network, call this example instead, and like that, and like that. It is flatten. Wonder what that does. Does it say? I think I just pressed the wrong thing there. It doesn't. Flatten? Oh, okay. That's interesting. Is that? So that's a class. I see. I'm going to up a class flatten, and then with that flatten, I'm not even using it. Oh, I see. I see. This is initialization. So I knew up that. Oh, I hate this sort of thing. So it's so much. It's so much better, surely, to be able to see what you're bloody dealing with. Um, maybe not. I don't know. People didn't like it this way. What is this? Sequential module. So we're returning a sequential, so that's that. And then this is going to need to be imported. And this one is a flatten. That's going to be imported. Whoa. nn.flatten. Okay. Yeah, okay. That makes sense. And so this, what was it called? Something linear unit, or what does it mean again? Define ReLU. Rectified linear unit. Let's have a read. So, in a neural network, the activation function is responsible for transforming the summed weighted input from the node into the activation of the node or output for that input. The rectified linear activation function, or ReLU for short, is a piecewise linear function. Piecewise, I know what that is. That's where you have multiple parts of a curve, put together in one equation. So piecewise equation, linear function that will output the input directly if it is positive, otherwise it will output 0. It has become the default activation function for many types of neural networks because a model that uses it is easier to train and often achieves better performance. That's because rectified linear activation, so piecewise linear function, rectified linear activation function. Let me see this again. Does it have a... Yeah, that's interesting. It's not like it's funny because it says it's linear, but so up until a certain point it's not decided, and then at at this certain point here, then it's like, okay, my probability just steeply climbs. I mean, what is it compared to, I wonder? But that's interesting. Yeah, okay. I think I understand why they're. I was gonna draw something like if you have like a collection of data, the operation where it's like searching for um, the lowest kind of point, and so it would do things like this, and then it will slowly work its way down. I think that decision, that linear unit, rectified linear unit, is helping it to not bounce too far and all that stuff because of its slow incline, or actually rather steep incline, but I'm not sure now. So I think I'll back off of that for a second. So going back to here, to define a network, we just done that. And then optimizing the model parameters. To train a model, we need a loss function and an optimizer. Loss function equals cross entropy loss, and the optimizer equals the torch optimizer.sgd model.parameters 1 exponential minus 3. Is it exponential? I can't remember. I should really know this. What does the E stand for on a calc? Exponent. Yeah. So it's like the power of thing. Let me see if I can. I really need to know this. I think it means to power of, but convert 1e3 to number. Here we'll show you how to convert 1e3 to a number. What does 1e3 mean? Enter scientific notation. So 1e minus 3 in decimal form is, yeah. So it's to the power of minus 3. 10 to the power of minus 3. 10 to the power of minus 3. Okay, cool. In a single training loop, the model makes predictions on the training dataset fed to it in batches, and back propagates the prediction error to adjust the model's parameters. Okay, so to train a model we need a loss function. Let's do that, and that'll be in my machine learning. Optimizing the parameters, creating models. Can I just move this out into their own function? Refactor, extract method, creating models. Oh, that's so good. That is just so good. Yes, I like that a lot. Woohoo, that's awesome. And it's interesting how it put a return, actually. Let me just keep that, model equals that. Because it needs it here. Yeah. And this one was, what was that again? That was some kind of working with data, yeah. Working with data. Let's do that again, refactor, introduce, extract, working with data. Okay. Oh, that's so cool. Right, model equals stat, and then optimizing model parameters. Oh, I need to do that. Optimizing model parameters. Refactor. Extract method. Optimizing model parameters. Nice. Okay. Let's move these in some order as well. That's right. Like that. Okie dokie. And then now it says optimize the model parameters. So I've got that. In a single training loop, the model makes predictions on the training dataset, fed to it in batches, and back propagates the prediction error to adjust the model's parameters. I'd love a little diagram of this, but let's just try this anyway. Local function train is not used. Cool. Uh, data loader. Let me not do that yet. What does this actually say? Train takes a data loader, takes the model, takes the loss function and the optimizer, and this one needs to really return these. So really it should be in here. And then I guess this is going to call the train or something. No, it doesn't. Okay. And so it goes through the batch in the data loader and then takes the tuple xy equals x to device to the GPU, y to the GPU. And 2 is on our neural network. No, it is not. It is on our network, yeah, because we've done it here. Creating models. Yeah, okay. That is correct. And then it creates prediction error model X, and creates loss function prediction Y, back propagation. So this is when it goes back. So I think this is it. Yeah, literally this. So I think what we're talking about here, let me try and draw this. I'm no expert. But if you have a graph, let's say that the kind of data looks like this. Maybe like that. Okay. And your model, let's say it finds this point and it finds this point, or these are kind of the lowest dips. Yep. And the loss function, compute prediction error. So the loss function is whatever mathematical model it's doing to try and find out which point to do. But I think the back propagation part is where you're essentially going, am I right? Let me go and figure out by doing a big jump. And then I'm like, I've got a, then I've taken a loss, and so then I come back and I try to jump back, but I can't. That kind of intuitive model there, and I have taken this from someone else as well. I'm trying to apply it here, and then you have and then it degrades again, so it's like goes through a loss function again. It goes through a loss function again. It's found the deep pit, but it still goes for the loss function. It can still go. It's still not the and it just keeps going down, and then we're really down to now an optimized kind of zero gradient loss backwards optimizer step if batch loss dot item batch times length. I think it's this kind of process that the back propagation goes through to get to its actual true answer here. Well, I guess we'll find out. That's my understanding of this. And it says if batch modulus 100 equals 0, so if it's every single batch of 100, the loss and current is loss dot item. So go and get the item, and if it's batch 1 times the length of x. Now what's x in this? X is the first part of the tuple. This is the structure. So batch times the length of the structure, and print the loss kind of auto size. Brilliant. Okay, well let's just give this a try then. So I'm not really sure where to put this. Really not sure. Train self.data loader model loss func and optimizer Z. Does this return anything? No, it does not. And I guess you can't do that in Python. I did not know that. And device will be, oh really, shouldn't you be passing the device in? I would think so, but I guess not. Cool. Let's give this a run and see what happens. What errors do we get? Using CUDA, then... Oh, why is that saying it twice? Working with data. This is a for loop. Device is that using? Run, working with data. Working with data runs. CUDA is that using? Okay, let's delete this. Because we're doing it here anyway. Although, to be honest, that really should... Yeah, let's do this. So set device. I like that way. That's nice. Let's do that. So gonna print that, and then we're gonna self device equals CUDA, otherwise CPU, and then it's gonna output that. Set devices run on the setup. So this is just something I don't really need anymore, working with data. I bet that's not even part of that, is it? No, it's not. It's part of the second one, creating models. Yeah. And then I can do that. But then, yeah, I want all this done. No, let's stick to this. Working with the creating models, done like that. Set device. Working with data, creating models, optimizing model parameters. Yeah, and really I think that's just confusing now, so I am going to move out of here. And I'm gonna delete this here. Is CUDA available? That's different. This can just be moved. Check if CUDA, no, set CUDA state. Cool. Something like that. Okay. Set CUDA state. Download data to get the data loader. Let's move this up. And working with the data, we'll go and do that thing. Then this will set up the device, and then I get the model back, and then I've got the optimized model parameters, and I train it. Now I need to actually do the rest here. So my wrist. We also check the model's performance against the test data set to ensure it is learning. So I'm really interested to see if this now works. So I've called train, so that really should function. So what have we got here? Main PY machine.learning run. Most recent call last. Line in module. Example data object has no attribute data set. Where is that? here. Oh, I see. It's what is going in train. I see. Okay. So these are two required methods for this. I see. I've got you. I've got you. Like that. Device. Self.device. Device. And then we've got the epochs. Epochs, I don't know what that is. Particular period of time. Okay. Data loader dot train data loader. Oh, that's worked quite well. Like that. The above functionality that has been prepared. Okay, cool. Now let's run it. It says none type object is not callable. X equals self.flatten. Flattens is none because it hasn't been initialized. Can I just do this? Apparently you can. Interesting. Oh, that's amazing. We have made progress, people. 5 epochs done. Okay, let me just go and correct my other shit then. So I've made lots of mistakes here. I did not know that you didn't have to do that. As I say, I come from a C++ and C# background, so logits, return logits. Okay. So I just need to, I think I need to just understand this a bit better. So let me figure out what's actually gone on here by studying the data that's come out. And I wonder if you can actually see that. Maybe you can now. It says, here's our neural network, starting dimension of 1, ending dimension of -1. Flattened. Then the linear what's it called again? I can't remember. Define ReLU. Linear something. Rectified linear unit. Rectified linear unit. So you've got this rectified linear unit stack is a sequential linear. Rectified linear unit. Linear 512. Out features. And then in one, so the training process is conducted over several iterations, epochs. So in one range, during each epoch, the model learns parameters to make better predictions. We print the model's accuracy and loss at each epoch. We'd like to see the accuracy increase and the loss decrease with every epoch. And so we'd like to see the accuracy increase and the loss decrease. Certainly decreasing, but the accuracy isn't always increasing, is it? Oh, it is. 32.6, 32.3, 32.9. So it's interesting. Yeah, okay, cool. Fine. And then a common way to save a model is to serialize the internal state dictionary containing the model parameters. Let's give this a try. Saving models. Define saving models. Model will be returned from this, I guess. Model to evaluate. Train. The model comes from here anyway on the run function. So self dot saving models will take model, and the model will be, goodness knows. I'm going to go back through this and figure out these property types, because I'm very interested to keep track of them. Say to Python state to model.pth. Model.pth, okay. We're already at the end, okay. Loading models. The process for loading a model includes recreating the model structure and loading the state dictionary into it. Saving models. Loading models. Return model. This model can now be used to make predictions. Oh yeah. Loading models. Let's do that. And this doesn't take anything, does it? No. Okay. And is the model is that always an example neural network? Model equals creating models. What does it actually return? Ah, it returns a model. Okay. Example neural network. That's what I meant to say. Returns a model. Like that. Okay, and then the optimizing model takes an example neural model, network, sorry, and then it does not return anything, but that I guess that's okay. Optimizing model, saving model, take that, and then that returns the model. Cool. Oh, have I been doing that on all these? I probably have as well. No, I have not. Okay, fair enough. Okay, so then I've loaded it. This model can now be used to make predictions. Classes equals model.evaluate. Right. Oh, okay. Def predict. And this will take model, example neural network, and test data. Where's that come from? Test data. Is the fashion mnist model, which is in my data class. Okay. And the data class is working with data, goes through to here, does that. So it is literally on here. No, it's not. So I need access to my data as well. Download data. This needs to be public. I know this doesn't actually mean public. I understand that. I just I like to be able to see what's available in my class. So now that's been assigned, and then I need to put this back over here. Okie dokie. And I probably don't need to return that, but you know what? That makes sense if I just make this local, like so, return data, and then download data will be, ooh, download data. I already did this. Downloaded data. Oh, I see. I see, I see, I see. Okay. Okay, cool. That goes into there. And then this will use that. Test data. Predict. Create models. And then predict. Okay, let's try it. Ooh, yes, this is exciting. This is very exciting. I should really store the output of that. Oh, I think I have actually. So yeah, I've already done this. So next time I'm going to run this, I'll check. I'll go to the load data instead, because this should be saved in my processed, wherever this said it was going to be used. Model. Oh yeah, I didn't pass it in. Ha. Okay, loading models. That one there. And it says it was saved to model.pth. What the hell is that? Where did you go? Model.pth, there it is. Okay. Haha, it's so cool. Okay. Check if file is available. Python. If is file operating system import. What does this take? A path. Cool. Let me put file path for saved data, saved model path. And I think I could put this here, so let's put the model.path, let's do that. Where are we? That one there. Yep. And yep. Oh, and I want to make that a string as well. Yep, cool. And this one will instead say this. Nice. Oh, we are so close to doing this. And then, wait, I was doing an if statement up here. So if that, then load. So I want to do if not. Is it not that? Is file. Does it return boolean? Well, here. Is that a boolean it returns? It does. How do you do a negative in Python? Python if statement. If that, da da da, greater than. That's helpful. If not, Python. If not. Oh yeah, okay. So if it's not a file, then save, else, load, and the loaded model will loading model will return the model, and thus I will have um, model equals like this, and then do that. Run. Predicted ankle boot. Actual ankle boot. Okay, cool. What did we? So this is with torch.no gradient model evaluate test dataset classes. So let's just check through what that actually does. So it gets whatever x is tensor 1. I don't understand that. Classes, prediction 0, argument x, classes y. Why is it outputting only once? Open console, no, terminal, no, debug, console. I don't know if I understand this yet. Backend Tiki aggregate is interactive backend, turning interactive mode on. Predicted ankle boot, actual ankle boot. How is it getting that value though? Debug. The predicted part is what? Predicted. I think I'm a bit tired now. I can't quite understand what's going on here. So we got it all working. We followed the guide. That's great. Quick start done. I think we need to go and actually understand what we've done now. There's quite a lot more to go, and I think this will be the route I take for quite a while, because I now want to start learning all the stuff that I want to learn for chemistry, biology, DNA and stuff, but in a machine learning frame. So awesome that we got this to work. It's using the machine learning, this neural network thing. It's done some prediction. I'm not quite understanding, where my question is. And so I think we'll do that next time. I'm tired now, so I'll have some lunch. Have a good one all. Have a lovely weekend. Bye for now.